All right, so we're going to talk about some important properties of the parabola. Before we do that, I'm just going to write this down. You don't have to write this down necessarily. We graph quadratics with y equals a times x minus h squared plus k using transformations. Whoops, that's how we've been graphing. What we're doing today is very different. We are not graphing. Notice. We are sketching. There is a difference between graphing and sketching. In fact, we kind of touched on this in one of the lessons, I think, where sketching does not require a grid. It does not require a proper scale. Okay, so we're not using graph paper. It's a sketch. The important thing about a sketch is that we label it properly. So we label whatever information we have. And depending on what you're sketching, it's going to be totally different. Okay? But this is very different from graphing with transformations. And so when we're going to do this sketching, it's all going to be based on the properties of the graph that we can get, in this case, from factored form. So the last unit was all about vertex form. We were completing the square. We were talking about the maximum or the minimum value. We were graphing in vertex form. This unit is all about factored form. Okay? So, important properties of a graph. When we sketch, you don't necessarily have to do this for your notes if you don't have a ruler handy, but your axes should be drawn with a ruler, so they should be straight. Okay? We do label x and y. I'm just kind of randomly drawing a parabola that opens downwards. And I'm doing this because we're going to visually talk about the properties of the graph that we're going to use for our sketching in this case. Ooh, I should have had this going further, actually. Let's have them both. Whoa. Go further. Just because I want to see the y-intercept. Okay, so the properties that we need to look at in order to sketch are the direction of opening, it'll be either up or down. That's something you have to think about. You have to plan for when you're doing this. Okay, we're going to find the x-intercepts, which in this case are here and here. The y-intercept, so we're going to find it. We're going to use it as part of our sketch. It's going to help us make sure that we're drawing it properly, that we have the right direction of opening. Okay, the y-intercept is going to be really helpful for that. And we're going to label it. All of these things are the things that have to be labeled. We don't have to label the direction of opening, but you have to show the direction of opening when you draw it. Okay? But we're going to label the x-intercepts and the y-intercept. Then we're going to find the axis of symmetry. Which I will use a short form, AOS, axis of symmetry. Remember, the axis of symmetry is a vertical line that goes through the vertex, so I'm just eyeballing this, obviously, in this case. The axis of symmetry will be x equals something, some value, whatever that value is. That is the value, the x value of the vertex. The axis of symmetry always goes through the vertex. And I'm actually writing it out in the order that we're going to do this. So when we do an example, you'll see. But we're going to find the x-intercepts, we're going to find the axis of symmetry, and then we're going to use all of that to find the vertex. Which is some point xy, right? So the x value will be the axis of symmetry. The y value will be whatever it is for that particular one. For the x and y intercepts, the x-intercept will be when y is 0, and the y-intercept will be when x is 0. And then the axis of symmetry. Well, there's something about parabolas that we have to notice that's going to help us determine the axis of symmetry. Okay, and it's this. This distance and this distance are equal. So I'm going to call them both d in this case. We're not going to use that variable really, but that's the whole point of the axis of symmetry, is any two values that are like horizontal. So if you go diagonal, it's different, right? But if you go horizontally from the axis of symmetry, you're going to go the same distance on both sides till you hit the parabola. So don't copy this part down, but like even if I went from here over or from here over, and you can see that my sketch is not properly drawn to scale because they aren't actually the same size, but mathematically they would be, right? Those would always be the same distance. That's what symmetry means. That's a good point, that when you're sketching, it doesn't have to be to scale. So if your parabola is not perfect, it's got to have a general parabolic shape. I said this before, it shouldn't go like this, because that's not what parabolas do, right? It shouldn't go like this and curve back on itself, because that's not what parabolas do. That's not a function. That's a big problem if you draw it like this. It should have a general parabolic shape, but it doesn't have to be perfect. Okay, and then with a sketch, the important part is that we're labeling things. And these are the things we're going to label. We're going to label the x-intercepts, the y-intercept, and the vertex, which kind of also counts as the axis of symmetry and the max and the min and all that stuff, right? So those are the things that we're going to label. We good so far? We were graphing with vertex form. If it helps, you can, vertices, that's weird. Vertex. This was vertex form. But now we're going to be using factored form. So what this lesson is all about is how do we use factored form to get these details that I've listed off on the right? How do I get those properties from factored form? So factored form looks like this. Y equals A x minus, for some reason we often use S for this. You'll see that in textbooks. I don't really know why. So S1 and S2, using a subscript because those are going to be different. They aren't the same. So you can imagine having some kind of quadratic expression like we've been working with, and you're going to factor it. And the first thing you might do is common factor, and that's going to give you this value, and that's going to tell you the direction of opening. Just like in vertex form, which is y equals a x minus h squared plus k. That a value tells you the direction of opening. If it's positive, it opens up. If it's negative, it opens down. So that's something we already know. It's the same a value in factored form. Whatever number is out front of the brackets, I don't care if it's a 2 or a 3 or a 4, that would be a stretch, but because we're sketching, we're not worrying about that. We don't have to do a stretch or a compression. We don't have to do that accurate thing. So we only care if it's positive or negative, if it's opening up or down. Okay, but it's the same as vertex form. What's different is that these are the x-intercepts. And notice that it's x minus S1. So my x-intercepts in this case would be S1, comma, 0 and S2, comma, 0. Because as we said above, x-intercepts happen when y is 0. So there's my y being 0. And my intercepts come from those two numbers in factored form. This is the same as when we were solving by factoring, that the solution came from those numbers inside the brackets, right? Same thing. By the way, this is new. This is not something that you do in grade 10. It's a little bit different. Again, the nice thing is it's fairly step by step. Any questions so far? So we're going to go through, and some questions are going to kind of tell you the order to do things, and some might not. But I think it's a great idea. Why not just do it in the same order every time? So we're going to find the x-intercepts, then we're going to find the y-intercept, then we're going to find the axis symmetry, then we're going to find the vertex. We'll have all those values, and then we're going to use those to sketch it and label things appropriately. Okay? All right, so this is the handout that you have. I think that's everything that we need there. Okay, so we've got our function over here, our quadratic, y equals negative 2x squared minus 8x plus 64. And the first thing we're going to do, I mean, the instructions tell us to do that, but even if it wasn't, the first thing we're going to do is we're going to find the x-intercepts. How are we going to do that? Well, we have to factor it first. So let's go ahead and start factoring. Y equals, I'm just rewriting this. You don't have to. And what I'm going to notice is it has a common factor. So I'm going to pull that negative 2 out. So watch. X squared plus 4x, right? So when I divide negative 8 by negative 2, I get a positive 4. And then positive 64 divided by negative 2 is going to be minus 32. Then I'm going to factor this. Now, b squared minus 4ac, I really don't need to be doing this. And I'm going to say why in a moment, but if you're in the habit of doing it, is 144. So this certainly is factorable. And I think it's x plus 8, x minus 4. 8 times 4 is 32. 8 minus 4 is 4. But it's got to be factorable. Okay? We're not going to be able to sketch something that's not factorable. We're not going to be able to sketch something using the quadratic formula. It's possible. I'm not saying it's impossible, but that's not what we're doing. So these will always be factorable. If you were having a hard time finding the factors, well, I would check b squared minus 4ac, and if it's not a perfect square, what that's telling you is you've made a mistake. I would guess in that step, factoring out the 2, you messed up a sign, or you forgot to divide everything by 2, or something like that. Okay, because it has to be factorable. Or there's a typo on the worksheet, or I've made a mistake in the question, or something like that. It has to be factorable. Okay? Okay, now that we've got it factored, we're going to find the x-intercepts. X-intercepts occur when y equals 0. So if I sub 0 in for y, now you might see, I might actually often, and you may choose to, it's totally up to you. Some people like routines, some people don't care. You might write it that way because that's the way we often see it. 0 on the right side. 0 on the left, 0 on the right makes no difference. Okay? You can flip sides of equations without changing anything. So they mean the same thing. And we often see it with 0 on the right, so you might write it that way. But some people don't like, if I went straight to this, some people wouldn't like it because y was on the left. So you can see that I've subbed 0 in for y. So it's just entirely up to you. I'm showing it this one time both ways just to sort of point that out. Okay, and then we solve this. This is an equation. The fact that we're about to graph or sketch a parabola has nothing to do with that. This is just an equation like we saw before. So we've got x is negative 8, and we've got x is positive 4. So my x-intercepts will be at negative 8, 0, and 4, 0, because the y value is 0, and those are the x values that we found. So there's kind of a fundamental, important idea here between the relationship of x-intercepts with solutions. But in your head, this could just be step 1 is factor, set it equal to 0, and solve for x. and those are your x-intercepts. Like, you could just do it that way. You don't really have to think about y necessarily. Okay? Is that good? What about the y-intercept? Well, the y-intercept is when x is 0. That's like a subscript I. It's like a little I. It's not, I'm not writing it like this. It's not yi. It's like y with a little I. Do you know what I mean by subscript? That's a short form for intercept. So I've got the x-intercepts up there. This is the y-intercept. So if I'm subbing in, I get negative 2 times 0 squared minus 8 times 0 plus 64. And all the x parts go away. And I'm just left with 64. So you don't have to show that substitution. You can just state that it's 64. The only reason I can do that is because I had the equation in expanded form. And in expanded form, when I put x in, 0 in for x, those parts go away, and I'm just left with the constant. That's almost the only thing that expanded form is good for in terms of the properties, is it gives us the y-intercept easily. Still good? Step 1, x-intercept. Step 2, y-intercept. Step 3, determine the axis of symmetry. Okay, this goes back to this diagram. The axis of symmetry is in the middle of the two x-intercepts. It's equal distance from the two x-intercepts. How do I find the middle of two numbers? This is something you do in grade 10, but in a different context. If you want to find the middle of two numbers, you could think of it as the average of two numbers. How do you find the average? You add them up and divide by 2. Or if you had 10 numbers, you would add them all up and divide by 10. Right? That's how you'd find the average of those. But if it's just two numbers, the middle is the average of the two, so you add them up and divide by 2. So my two numbers are negative 8 and 4. So this is something you need to remember, but it's the same every time. So if you're doing the practice and you get to this step and you're like, I don't know what to do, and you come up and ask me, I'm going to just say, well, look at the lesson. What did we do in the lesson? Because you do the same thing every time. These numbers are the x-intercepts. And you don't have to show that middle step. But I think you should show the substitution. So axis of symmetry equals negative 8 plus 4 divided by 2, which gives us negative 2. So technically, our axis of symmetry is x equals negative 2, but I'm okay if you just write AOS equals negative 2. Sometimes we are picky in how we say the axis of symmetry. It's a line, so it should be written as x equals negative 2, because that's the equation of a line. But for this, we don't have to do that. We're just trying to find the value for the axis of symmetry. So you can just say AOS equals negative 2. That's fine. Still good? Step-by-step process. There's your third step. Take your two x-intercepts, add them together, then divide by 2. Don't do this. Negative 8 plus 4 divided by 2. Why did that say negative 6? And that's the wrong answer. Yep. Good. It's a bedmass mistake. This is dividing 4 by 2, then adding it to negative 8. Whereas what I wanted to do was add those two things first, then divide by 2. and I get the correct answer. Or if you use fraction, -8 plus 4 divided by 2, that's going to work as well, right? So be careful punching it into your calculator, but your calculator is going to be useful for that. I've got my axis of symmetry. Last thing before we sketch is find the vertex. How do I find the vertex? Well, the x value of the vertex is that axis of symmetry. So what I need, is to find the y value. And then I've got it. Okay? Well, if I have an x value, that's the whole point of an equation. I can use an x value to find the y value for that function, for that relation. So I'm going to do at x equals -2, which is the x value, the axis of symmetry, and the x value of the vertex. I'm going to sub that in, and you could sub it into whatever version you want. You could sub it into the factored form or the expanded form. It's possible that factored form you could do it in your head more easily. Or you might prefer to write it this way. I don't know. That's up to you. Okay, -2 squared is +4 times -2 is -8. -8 times -2 is +16 plus 64, and that works out to 72. Therefore, our vertex is -2, 72. Okay? Finally, we get to the sketch. So again, you should be using a ruler to draw your axes for a test at least. Now, when I drew my axes, you could just draw a cross. You know what I mean by that? Like, you don't have to have them off to the side the way I've done it. It's up to you. But I did it this way because I know that it opens down. I know that my x-intercept is -8 and 4, so it's more to the left than it is to the right. So that's why I've got my x-axis going off to the left more. And I know that my y-intercept and my vertex are up very high. So that's why I have my y-axis going up higher. You wouldn't have to do that. This is not to scale. You're not drawing a grid. You're not using graph paper. But it has to be reasonable. It should have some sense of what the parabola actually looks like. So I'm going to do a couple things. I am going to mark my x-intercepts. And notice that I did -8 about twice as far as 4. It might help you, if you have your ruler out anyway, to actually have it kind of double. You know what I mean? So how would I do that? I would just say, like for mine, it doesn't have numbers on it, but it looks like I went kind of 3 big lines to get there, so I should go 6 the other way. 1, 2, 3, 4, 5, so not quite for me, but close enough. That might help, I don't know. Then I'm going to think about where my vertex is. So my vertex is at -2, so that's, I don't know, about there. And I'm going to go kind of up to the top. There's my -2. What's the y value of my vertex? 72. And it opens down. So I'm going to do this, and I'm just going to kind of make sure that I go through the x-intercept. In fact, you might draw the parabola first and then just mark where you went through. But it's a good idea to have a target. Otherwise, your parabola might look kind of wonky. It might not look to scale. See, like that's pretty bad the way I've done it there. So I'm going to go like this. That's better. And I always draw my parabola and then mark the y-intercept at the end, so that, because if you try to mark the y-intercept, you're going to force it and it's going to look weird. And our y-intercept in this case was 64, so I draw a little line and I label it as 64. So notice that I've labeled both x-intercepts, -8, +4. I labeled the vertex as a point, but I also marked it on the axes, so -2 and 72, and I labeled the y-intercept of 64. So you have to label the intercepts and show the values of the vertex in your sketch. But that's it. Very different from the graphing that we did. But it gives a general idea of what that parabola would look like. Any questions? All right, on the back, we've got 2 more examples to do. Now, I'm not going to take the time because we've already gone fairly long with this lesson. I'm not going to do the entire thing. What I'm going to do is I'm going to show you the first couple of important steps of both of these. Then I'm going to let you finish them, and I'll put up the solution so you can look at them, or if you want, you can just go to the homework as long as you're checking your answers there. But both of these are different in a subtle way. So I'm just going to go over how they are different for each of them, but then after that, the process is the same. Okay. Notice that it does tell me what to do, A, B, C, D, E. It's the same steps in the same order. Step number 1 is find the x-intercept, so I have to factor. And what do I notice? This is that type that's missing the constant. So it's got a common factor. So maybe you factor out the 4 first. Because that's what we did before. But if that might actually confuse you, so really what you want to do is you also want to factor out the x, right? And we need to know that when I've got a 4x that means my x-intercepts are what? One of them is +3 from that bracket. The other one is 0, right? So that's something we need to know how to do. And that means that my y-intercept, so y-intercept happens when x is 0, and if I put zeros in for x, I get a y-intercept of 0. If I have an x-intercept of 0, I have a y-intercept of 0. You have to. Okay, actually, I'm going to do the last couple steps. I'll do them quickly, but for the axis of symmetry, it's 0 plus 3, and I divide by 2. And that gives me 3 over 2, or 1.5, so a decimal, or fraction. Whichever one you use, it doesn't matter. Again, people might be scared of fractions, scared of decimals. The next one is the vertex. So I'm just plugging this in, 4 times 1.5 squared minus 12 times 1.5. I don't have to be worried about this because I'm just going to use my calculator. I got -9. So once in a while, you're going to get x values for your vertex that are fractions or decimals, but not a big deal. We're just punching it into our calculator anyway. And we're not graphing this accurately, so it really doesn't matter what that number is. Okay, so I'll do the sketch and put it up after, but there's the details for that first one. It's going to go through the origin because it has an x-intercept of 0 and a y-intercept of 0, opens up. Otherwise, they all kind of look the same when you're sketching because there's no scale. And finally, for this one, b squared minus 4ac, this is what I want to do for this one. Watch what happens. So b is 12, 12 squared minus 4 times 9 times 4. Is that right? A is 9, C is 4, B is 12. So this looks right. Watch what happens. What do I get? Aha. 0. What does that mean? When we did the nature of the roots, what does that mean when I get a discriminant of 0? Very good. 2 equal roots. One solution, 2 equal roots. That means when I go to factor this, I get the same thing twice. How did I factor that so quickly? Well, here's the pattern. If you can remember this, save yourself a world of trouble. If you do b squared minus 4ac, we know that these are all going to be factorable because that's the only way you can sketch. It's going to factor. So you might not check the discriminant. But if you notice this pattern, or if you do check the discriminant and you get 0, the first value is the square root of that, and the second value is the square root of that. That's the pattern. That's the relationship. Square root of 9 is 3. Square root of 4 is 2. The sign will be the same sign as what's in the middle there. But you could just factor it normally. That'll work totally fine, just like in this case a complex trinomial. The last little bit of the pattern, if you're not checking the discriminant, is I take this number times this number, double it, and that has to be the middle number. So 3 times 2 is 6, and 6 times 2 is 12. So that's why that relationship works, and it works out to 3x plus 2 all squared. And what does that mean when I go to graph all of this? So the x-intercepts are when y is 0. So I get 3x plus 2 squared equals 0, which means my x-intercept, I only have 1. It's negative 2 over 3. But I get the same one twice. That's why we say 2 equal roots. Because we get the same root, but we get it from both those places. So this is a technicality of mathematics, but it does have 2 roots. They just both happen to be the same. Like I said, there's one, there's the other. And there is something like an important distinction to that, but it's not really important for our course. Okay, very quickly, the y-intercept. Y-intercept at x equals 0. So that's going to be 4. So this is the last thing that I need to get to so that people know what to do, because this is a little bit strange. I don't have two x-intercepts to add together and divide by 2. So how do I find the axis of symmetry? Well, you could think of it, you got two options here, folks. You could think of it as use the two roots. So both roots are negative 2 over 3. And then divide that by 2, add them together and divide by 2. But what's the middle of a number and itself? It's just that number. Are we following this, or am I going too fast here? And what you really need to know is that in this case, the vertex is on the x-axis. So here's this graph completed. It opens up, and there you can see the other one there as well. It opens up. Axis of symmetry is negative 2 over 3, and you can see that it's on the x-axis. So that's probably what you want to think of when you have two equal roots. It doesn't cross and cross again because it only has one x-intercept. That means the vertex has to be on the x-axis, which means the axis of symmetry is just that number. So you plug that number in to get the vertex, but of course the vertex is going to be at 0. It has to, because that's where the vertex is.